All right, today we're going to pick up finishing talking about the atomic theory and parts of the atom. Yesterday we talked about the first people's atomic theory. Democritus proposed the uncuttable atom, uh, and Aristotle proposed that there are only four elements. Democritus was mocked; he was actually put in jail. Um, and for about the next 2,000 years, people kind of believed Aristotle was correct. I didn't really look anything of what Democritus had to say. And then in the late 1700s, John Dalton came up with his atomic theory. And his first postulate was almost identical to Democritus, that atoms were uncuttable. And that was really the first. He was the first person Dalton was to offer proof of of the structure of the atom. Then Dalton didn't really have a lot of description in it. And then the first person to really try to build upon Dalton's work was about 100 years later, would have been J.J. Thomson, who did the cathode ray tube experiment. Okay, he found the electron, I believe in the plum pudding model. Remember, that was the plum was the nucleus, and the pudding would be the electrons, and just the electrons surround the nucleus. So picking up from there today, the next person we'll talk about was actually a student of J.J. Thomson, was Ernest Rutherford. Okay, he performed what was called the gold foil experiment. Okay, the gold foil experiment. We know that gold, we know that metals are very malleable. They can be hammered out into a sheet, and gold is one of the most malleable metals. Okay, so think of a piece of gold foil about like a piece of aluminum foil. Okay, that's basically what they were doing. And Rutherford wanted to find out how big the atom was. Okay, how big the atom was. So he fired positively charged alpha particles at a piece of gold foil, which was even thinner than aluminum foil. Now, what he expected to happen, was that he expected them just to pass straight through. Okay, he expected these alpha particles to pass straight through. Um, kind of if you look at the picture, kind of like the one on the top did. Okay, the two on the top and the one on the bottom, he expected those to pass directly through, but that is not what happened. Okay, he found that most of them passed directly through, but in the center there was a positive nucleus. There was something in there that the alpha particle was hitting or bouncing off of. So you can see the closer they got to the middle, the more that these things kind of bounce. The one dead in the middle, you kind of curve back. The other one just right below it kind of made a 90-degree angle. And he postulated that there had to be something in there. Now they knew that the nucleus was positive because they knew the whole thing was neutral, the electrons were negative. So Rutherford is credited with finding the proton. Okay, finding the proton. James Chadwick is the person with the neutron. I don't really have a lot of information on him, but Rutherford is credited with finding the proton. Okay, finding with the proton because he knew that this positive center was a small positive center. Okay, Niels Bohr was the next person with this. You've all probably seen the Bohr model of the atom. Who's watched a cartoon in their life? And you see, someone get their head hit, or even the Big Bang Theory, you see the thing swishing around, going around the atom like on a rope. That's the Bohr model of the atom. Okay, that is the Bohr model atom. Known as the planetary theory. I said that they orbit the nucleus, they go in the circle, and they go around it, kind of like the planets orbit the sun. Bohr said these electrons could only exist at these certain energy levels. They were like steps on a ladder. Can you be standing between two steps on a ladder? No. You have to be on one step or the other. So Niels Bohr said, same thing. Electrons had to be in one orbital or the other. Okay? And that's the key thing. That's the key phrase there. They have to be in one orbital or the other. Okay? They have to be in one orbital or the other. They cannot be between orbitals. They cannot be between these orbitals. So Bohr's model worked pretty well for hydrogen. Okay? It was actually originally the Bohr model of the hydrogen atom. And on the hydrogen atom, it worked. The problem was it didn't work for any other atom. Okay? It didn't work for any other atom. So they built upon this. Okay? And this is where we are now. Okay? The Bohr model shows electrons in orbit around the protons in orbit around protons and neutrons. Our modern atomic theory is called the quantum mechanical model. Bohr said they had to be there. Okay. The quantum mechanical model says they are most likely there. Okay. When you look at the Bohr model is pretty much correct. Okay. When you look at an atom, there are definite orbitals that are there. 99% of electrons are probably there. Okay. But they're not all in that exact orbital. The quantum mechanical model says that they are most likely there. That's the probable place. If you would plot all the electrons in an atom, you would probably get, with a heat map showing the density, you would probably get it to look like the Bohr model of the atom. But the Bohr model says they have to be there. The quantum mechanical model says they are most likely there. That they are most likely there. Any questions about that? Kind of boring. Structure of the atom. So this is building upon everything. There are two regions of the atom. Okay, the nucleus and the electron cloud. The nucleus is composed of protons and neutrons. Because they have the protons, they have a positive charge, and almost all the mass of the atom is in the nucleus. Okay, the electron cloud is made up of electrons, and they surround the nucleus, and that's the region where electrons can be found. And it's the most of the volume. You got to think about this. On Earth, where is most of the mass of Earth? Where is most of the mass on Earth? If you think of the Earth as an atom, you have the physical Earth, and then you have the sky. Where's most of the mass? The Earth. Okay, that's where it's the most dense. Where's most of the volume? The sky. Okay, that's a very good way of how the atom looks. Okay, the atom looks. Now you can see in this picture there's s, p, and d orbitals. This thing is a heat map of where the electrons are found. Okay, so you can see the darker the color, the most often the electrons are there. There's three different types of orbitals. We'll get to talk about those next unit. Okay, we'll talk about those next unit. But you can see the heat map. Bohr said they had to be there. The quantum mechanical model says, hey, you look at these. This is where they're most likely to be found. Parts of the subatomic particles of the proton, neutron, and electron. Protons and neutrons have the same mass. You can see that. I mean, the neutron is slightly heavier. Okay, but it's not that big a deal. So the neutron and proton are the same mass. The difference is the protons are positive and the neutrons are neutral. The electron is a lot smaller. It's almost 2,000 times smaller than the proton and neutron. So if I want to count, if I want to look at things, the atomic number is the number of protons that an atom has. Okay, let me pause it. All right, so the atomic number is the number of protons. It is the whole number value. Okay, so we can look at different things. The atomic number on this periodic table is in the upper left-hand corner. So Levi, what's the atomic number of sulfur? Sulfur has a symbol of S. Top left. 16. Sulfur has an atomic number of 16. So Smiley, what else? If the atomic number is 16, what other two things are also 16? The atomic number equals the number of protons. It's the same as the number of electrons. So if it has an atomic number of 16, it also has 16 protons and 16 electrons. Well, Darius, how many protons does iodine have? 53. Proteon, how many electrons does calcium have? How many electrons does calcium have? Far left-hand side. It's yellow. Calcium? Look at the third yellow one down. 20. So it has 20 protons, 20 electrons, has an atomic number of 20. Let's see here. Stephen, what about, what is the symbol of holinium? The symbol of selenium. What? It's number 67. It is at the bottom part of it, okay? It's at the bottom part of it. In that ugly, like, gold. H-O-Ho! All right, so, Jaden, I want you to tell me the number of protons that the elemental, whose elemental symbol is AS. The number of protons of the element whose symbol is AS. What? 18? AS, not AR. Number of protons of the thing is a symbol of AS. Mm-hmm. What? Yes. Number of protons. That's the. No. 33. 33. Okay. That is a metalloid. Okay. Now we're going to come back. We're going to ask some more questions about this. The mass number is the number of protons plus neutrons. The mass number is not given on your periodic table. The mass number is not given in your periodic table. Tomorrow we'll calculate mass number. Okay. It is not given in your periodic table. Instead, the periodic table gives the average atomic mass. Gives the average atomic mass. Okay. Average atomic mass. So, Levi, what is the average atomic mass of boron? What's the average atomic mass of boron? No, from the top. No. What is the average? Somebody else. What's the average atomic mass of boron? 10.81. Okay, the average atomic mass is typically a decimal number. Gosh, Levi, you're such a boron. You're such a boron. I just want to say that joke. Let's see here. Fladarius. What is the average atomic mass of chlorine? Cl. The average atomic mass of chlorine. Cl. Yes, sir. Cl. Yes, sir. No, that's the atomic number. I'm looking for the mass. But it is the atomic number is 17. So for there's what's its mass? Average atomic mass. It says atomic weight, atomic mass, same thing. Did you find chlorine? Hey, Fladarius. The blue one.
Like the weight or something?
What's the weight of the mass of the weight? Potato. 35.45. Smiley. What is the? I heard Smiley's getting pretty serious with his girl.
Oh, man.
Smiley, I want you to tell me the name of the element. The name of the element that has a mass, an average atomic mass of 91.224. The name of the element, and I picked this one specifically for you. That has an average mass of 91.224. You know why I picked this one? Does anybody?
No.
That's how much you weigh.
No.
Which you said that again, Thompson?
I'm looking for the name of the element that has a mass of 91.224. That's the symbol, now it's not the name. Let me give it a second, Levi. Let me see if Smiley can get it.
Oh, he called you a jerk?
No. You find it, Smiley?
You said 91?
91.224.
I got it.
It has a mass of
It's
91.224.
in pink, ain't it?
Yes, sir. Yes, ma'am. Yes, ma'am.
91.
You see it?
Zirconium. You know why I picked that? You know what fake diamond is? Cubic zirconium. All right, last one. Who haven't I talked to today? Oh, Dominic. I want you to tell me the number of protons present in the element that has a mass of 83.798. So number of protons of the element that has a mass of 83.798. I'm Batman, so this element really hurts me.
Kryptonite.
I'm asking for the number of protons, though. Okay, I'm asking for the number of protons. That has a mass of 83.798. I want the number of protons. Well, what element has a mass of 83.798? Krypton. So how many protons does Krypton have? 36. Okay. So that's a lot of your homework today. Okay. Using the periodic table, just like that. Okay. Any questions about that? All right. So we'll end the day.
Yes, sir.
I'll get this posted.